Okay, the next sort of problems that go along with this standard 7.2, solving exponential equations, will look something like this. You're going to be solving exponential equations and your variables are going to be up in the exponents. And you have to solve this equation for x. You've got to figure out what x is equal so that both sides of the equation are equal. So I have 3 raised to the x plus 4 power has to equal 3 raised to the 2x minus 1 power. And minus some of those of you that may have seen the answer before I erased it. Okay, can anybody figure this out in their heads?
Can you just make 2x plus 4 equal to 2x? Or no, x plus 4.
You're telling us exactly how to solve it. Someone in the other class said, well, wouldn't 5 work? What's 5 plus 4? So I got 3 to the 9th, right?
Oh.
What's 2 times 5 minus 1? 9. So I got 3 to the 9th on this side, so the answer is 5, right? That's what somebody said in the other class because they just plugged in numbers until it worked. They got the same thing on both sides of the equal sign.
So it actually works.
Okay? Yeah, but here's the problem. They're not all going to be that simple. Okay, but yeah, I mean, that's how an equation works, right? If you can figure out what number to plug in for x so that both sides are equal, I mean, unfortunately, they're not all this simple. Okay? Now, what Dakota was saying is he's saying, well, if I have 3 raised to this power on the left side of the equal sign, and I have 3 raised to this power on the right side of the equal sign, well, in order for them to be equal, wouldn't this exponent here have to equal that exponent there, since they both have a base of 3? 3 raised to this is equal to 3 raised to this, so wouldn't it make sense that x plus 4 has to be the same number as 2x minus 1? Whatever x plus 4 is, has to be equal to 2x minus 1 in order for these two sides to be equal to each other? Is that logical? Can you solve this for x? Hope so. Okay. Subtract x from both sides. Add 1 to both sides. X equals 5. Simple, right? All you gotta do is set the powers equal to each other, as long as they have the same base. They don't have the same base. Nope.
Oh.
Dakota said divide by 4, but the problem is you can't divide the 8 by the 4 because the 8 is being raised to a power first. You'd have to raise it to the power, then divide by 4. Because you got to do exponents before you do division. Can't, same thing with multiplying. You can't multiply until you raise it to the power.
So you do the powers first.
In order to solve them, like the last problem, what did I have to have?
Oh, you have to add like 3 to it, or 3 to the 2. Like 3 to 2, or no. X, no, 3x plus 2. Does that work?
What?
Oh, wait, no. But you have to like raise the 2 to like 3.
You're close.
But you have to like add that into the equation. So it would be 3x.
He's
plus
trying to rewrite it so they have the same base. He's trying to make so that they both have the same base. This has got a 2, this has got an 8. Do you have something?
Oh, no, I was just agreeing. Is there parentheses in this?
Yes?
Okay.
Come
Are there
on!
parentheses around the exponent?
I'll give you a hint. It's right here.
Let's put 2 cubed.
What's 2 cubed?
8.
I'm going to change 8 to 2 cubed. If you change 8 to 2 cubed, then you have the same base on both sides of the equal sign.
You should have to
Where do you put the cube die in?
Okay? Yep.
Oh,
Like that.
gotcha.
So I still have 8 raised to the 4x plus 5 power, right? That still says 8 to the 4x plus 5 power. I've just rewritten how I express 8. 8 is 2 to the 3rd power. Okay? Now, if that can't be done, you have to learn logarithm, which is later on. Okay? But all the ones that are going to be assigned for you today, you will just have to take one of the numbers, or both of the numbers, and rewrite them so they have the same base. Okay? So 8 could be rewritten as 2 to the third. Now, you have a power to a power. What do you do when you have a power to a power? Multiply. So I got 2 to the 3x minus 1 equals 2 to the what?
12.
12x
Plus 15.
plus 15. So 2 to the 3x minus 1 equals 2 to the 12x plus 15. Now what can you do? Set them equal to each other and solve. Yep. Set the exponents equal to each other and solve. So 3x minus 1 equals 12x plus 15. I'm thinking you guys can probably finish that one. Once you get it, go ahead and tell me the answer. Fraction is fine. I don't think it comes out very nice.
9, 4. No,
Fraction.
9, or negative 9, 4. No, or is it 4? 1 second.
Negative 16 ninths. Yeah.
Negative 16.
Yep, because you subtract 3x, you'll get 9x. You subtract 15, you get negative 16. So negative 16 ninths. That's where guessing and checking wouldn't help you much, obviously, on something like this.
I got it.
Negative 16 ninths would be your solution to this one. Okay? One more. First of all, before I show you that one, the fraction 1/4. The fraction 1/4 could be rewritten as 2 raised to what power? 1/4 could be rewritten as 2 to the
Negative 1/2.
Negative 2.
negative 2. 2 to the negative 2
yeah.
is 1/4. What's 3 to the negative 2?
1 9.
1/9. What's 4 to the negative 2?
1/16.
1/16. Remember, guys? 4 to the negative 2 power
Oh, you go
equals
to the bottom.
1 over 4 to the positive 2 power. Because you can't do negative exponents, so you move them down to the bottom. Yes?
Yep.
So it's 5 to the negative 2 power.
Or 1 20.
1/25. Okay, got it? So, just make sure you're ready for that. If you see this, that's fine. What are you going to change 16 to?
4 to
It's
the
got to have the same base.
4 to negative.
4 to the negative 2. 1/16 is the same thing as 4 to the negative 2 power, and this problem is exactly like the last one then. Okay? 4 to the x plus 3 equals 4 to the negative 2 to that power. Power to a power. You multiply. Negative 2 times negative 2x would be 4x. Negative 2 times negative 3 would be positive 6. So I have 4 to this power equals 4 to this power. Set the two powers, or the two exponents, equal to each other. Solve, and you get x equals negative 1. Okay? So I just wanted to refresh your memory. Just because you see fractions, don't let those fool you. All right, it just means you have negative exponents is all. Not a big deal. Okay? All right, so if you can do that, you can do all the other ones on the second set of practice problems that I'll show you here. Or actually, they're just on the calendar. Make sure you look those up for today. That should be about it. Go ahead and pause, please.